Okay, so that's the formation. The enthalpy change when 1 mole of a substance in its standard state is formed from its constituent elements at standard conditions of 1 atmosphere, 298 Kelvin temperature. So sodium chloride, H2SO4, and propane, we can see that they all have a coefficient of 1. This is what is formed from their constituent elements. Sodium chloride, the constituent elements are sodium and chlorine. H2SO4, the constituent elements are hydrogen gas, which is H2, sulfur, which is a solid, and then oxygen, which is a gas, so O2. And propane, the constituent elements are carbon and then hydrogen gas. And so to balance it, we place in front of them these values to ensure that the product side is balanced. We should always make sure that in formation we are forming 1 mole of the substance, so we do not balance the product side. Now, combustion. We said that it's the enthalpy change, or we can say that it's the heat that is evolved, because when you are burning, heat is released to the surroundings. When 1 mole of a substance in its standard state is completely burnt in excess oxygen at standard conditions. And I'm saying that even though burning and combustion are similar, they are not the same. In fact, burning is a type of combustion that involves a flame. But when we say combustion, it may involve a flame or not. Are you getting that? Burning always involves a flame, but combustion can involve a flame or not. There are times where in the human body combustion processes do take place, what we call oxidation processes. There is no flame, but it is still called combustion. So know this very well in your chemistry as you are building your chemistry and all of that. So when someone says burning the same as combustion, not necessarily. Burning is a type of combustion that involves a flame. But when you say combustion, it's a general term for burning that involves a flame and other processes that do not involve a flame. So burning is actually a type of combustion. So enthalpy of combustion. You are burning 1 mole of a substance in its standard states in excess oxygen at standard conditions. So how do we write that? So let me take the first example. So please, up here, we should know that because the reaction is a formation reaction, we put the enthalpy change, the standard enthalpy change here. So standard enthalpy change of formation of H2SO4 and standard enthalpy change of formation of propane. Now we come to combustion. Let's start or begin with propane, which we used in our previous example. Propane is C3H8. So we are going to burn this in excess oxygen. And keep this in your mind always. Whenever a hydrocarbon means hydrogen and carbon. So a hydrocarbon compound is a compound which contains hydrogen and carbon atoms only. So you can see that in this example, C3H8, this contains carbon and hydrogen only. So we call this hydrocarbons, and they are special groups of organic compounds. Whenever you burn a hydrocarbon and oxygen, whenever you burn hydrocarbon and oxygen, you are always going to produce carbon dioxide gas and water. This is very, very basic in chemistry. Always, always, whenever you burn a hydrocarbon and water, you produce carbon dioxide gas and water. So here we are going to balance our reaction. That is, if it is not balanced. What do you think we can do to balance this reaction? By 3. Okay, so let me do that for you. So this is a 3. The water side by 4. Okay. So now carbon is balanced, right? Oxygen on the product side is what? No, I mean, for CO2, the oxygen is what? No, I mean, how many oxygen atoms? Good. And the water side is how many? 6 plus 1 gives us what? Good. We have O2 at the reactants. So what do you put in front of it? Good. So we put 5 here. So now here, this becomes standard enthalpy change of combustion, delta HC. Now let's do the second example for combustion. Then move on to the other type of enthalpy change. So now let's look at methane, which also can be produced by decomposition of organic matter. So you are burning methane in excess oxygen, and by virtue of it being a hydrocarbon, we are going to produce carbon dioxide gas and water. So how do we balance this? Water by 2. The oxygen at the reactant side by 2. What do you think? By 2, okay. It's balanced, right? Good. So that is standard enthalpy change of combustion. Very simple. So that's the second enthalpy change we have seen. We have seen formation, we have seen combustion. Now the third one, standard enthalpy change of solution. And I can ask you to define any of them. Standard enthalpy change of solution. Please let me correct this. So here, let me put your delta HC here. It's always important to write that. Standard enthalpy change of solution. So now let's look at that. Now, solution. Here we are looking at what happens when you introduce an ionic substance into water. We understand that water is a polar solvent. And so when you introduce a polar solute like an ionic substance into it, the ions interact among themselves to generate hydration energy, which results in dissolution of the ionic compound. So we say that it is the heat that is released. And don't forget that combustion is exothermic, you know that, because heat is released to the surroundings. Now, in enthalpy of solution, we say that it's the enthalpy change or the heat released or sometimes absorbed when 1 mole of an ionic substance is dissolved completely in excess water at standard conditions. At standard conditions. These enthalpy changes are very, very important. very soon we are going to be looking at how they are all relevant in the scheme of other things. Because virtually, one way or the other, we are surrounded by heat. Okay. We said that the enthalpy change of solution is the heat that is absorbed or released. In other words, is the enthalpy change when 1 mole of an ionic substance is dissolved completely in excess oxygen. You know that a solute plus a solvent gives us what? A solution. So here, now what an ionic substance is the same as an ionic compound. It's a compound. You were asked to do bonding, right? So when we do bonding, we are going to learn that there are generally two types of bonds: interatomic bonds and intermolecular bonds. We will learn that under interatomic bonds, we have ionic bonds, we have covalent bonds. We know that ionic bonds are also called electrovalent bonds. Covalent bonds, too, under covalent bonds, we have dative covalent bonds, we have polar covalent bonds, we have non-polar covalent bonds. Then we also have metallic bonds under interatomic bonds. Then when you go to the intermolecular, that's where we have the hydrogen bonds and the van der Waals forces. We are going to be looking at that. So when we say a substance is an ionic substance, what it simply means is that the bond that's existing in that compound is an ionic bond. And we know that ionic bond is a bond that is formed between atoms of low ionization energy and other atoms of high electron affinity. So, respectively, we are talking about metals and what? Non-metals. And it also involves the sharing of electrons from one atom to another. We'll be discussing all of that since it is part of the things you need to know. So, when you introduce sodium chloride, which we know to be a solid, into water. So let me put aqueous. Aqueous here stands for water. We are going to have a certain interaction between the water molecule and the sodium chloride by virtue of all of them being polar. And so the interaction is going to result in the generation of hydration energy, which is going to dissolve the sodium chloride. So at the end of the day, we are going to have sodium chloride in aqueous solution. So this is NaCl as a solid. But once it comes in contact with water, the ions interact among themselves to break down the sodium chloride, and then we have NaCl in aqueous form. So here, the enthalpy change here will be written as enthalpy change of solution. You're not feeling well, eh? Enthalpy change of solution. So we can also have another ionic substance like potassium chloride, which is solid, plus aqueous, and this will give us potassium, aqueous potassium chloride, and the enthalpy change here will still be solution. So enthalpy change of solution. So that's what enthalpy change of solution is. Very simple. You dissolve an ionic substance in water. 1 mole of an ionic substance in water at standard conditions. Enthalpy change of neutralization. So for that one, something begins to come into mind. Enthalpy change of neutralization. So again, let me remind you, if the question says define enthalpy change of solution, at standard conditions will not come. But when the question says define standard enthalpy change of solution, then you need to add at standard conditions. So don't forget that. So now we move on to standard enthalpy change. Standard enthalpy change of neutralization. And by now I know you know what neutralization is. Now, we know that in a typical neutralization reaction, we are looking at something that is taking place between an acid and a base. And it is typically an exothermic reaction. Neutralization reactions are largely exothermic. And because heat is released to the surroundings, we can define this as the enthalpy change or the heat released when 1 mole of an acid is neutralized by an alkali or a base. Alkalis are types of bases, but not all bases are types of alkali. When we say an alkali, it's a type of a base that dissolves in water, or it's a soluble base. But we have some bases that do not dissolve in water. So even though we see that all alkali are bases, we cannot say all bases are alkali because some bases do not dissolve in what? In water. The way you say all medicines are drugs, but you cannot say all drugs are medicines. Okay. It's neutralized by an alkali to produce 1 mole of water at standard conditions. So for this, I wouldn't write more examples because it's already bright knowledge. Okay. So we have HCl plus sodium hydroxide giving us NaCl aqueous salt plus water, the liquid phase. When you're done, then let me know. Then I move on to the next one. Okay. The next one, enthalpy of hydration. Standard enthalpy of hydration. Standard enthalpy of hydration. Now, in hydration, essentially what is happening is where you have the ions of a substance in their gaseous form transforming into hydrated ions. Now, hydro has to do with water, and hydros means without water. So in chemistry, we have hydrated salts and then we have anhydrous salts. So when we say enthalpy of hydration, what it simply means is an example or a case where you have 1 mole of ions in their gaseous form forming hydrated ions. Hydrated ions means that at the end of the day, the ions are going to exist with some amounts of water. Why is this important? This is important because you see, the water molecules are polar, which means that they are attracted to charged ions. They are attracted to charged ions. So, like I indicated to you earlier, when you introduce a polar solute into a polar solvent, the ions interact among themselves to generate hydration energy. To generate what? Hydration energy. It is that energy that results in the breakdown of the ionic substance. That results in the breakdown of the ionic substance. So when we say an ion is a hydrated ion, it simply means ions that are dissolved in water. Simple. Ions that have been dissolved in water. So when we say the enthalpy of hydration, we can say that it is the heat evolved. Evolved means released. Heat evolved when 1 mole of ions in the gaseous states forms 1 mole of hydrated ions, which means that ions that have been dissolved in water under standard conditions. So this underpins or underlines how substances do dissolve in water. How substances do dissolve in water. So for example, let's say we have, okay, so let me use um, a gaseous ion like M, and the charge is P plus. Now this is a gaseous ion. When this reacts with a certain moles of water, what we get is going to be the MP plus as a hydrated ion. So now the ion exists in water. Initially it was in the gaseous state, but after coming in contact with water, it is now existing and it is seen to be dissolving in the water. Is that possible? Yes. Why? Because that ion is polar by virtue of having a charge. Water is also polar. And so there's going to be interaction between the ions, thereby generating what we call solvation energy. Or sometimes we can say that a solvation sphere is generated around the ion. And that process is what we call hydration. Hydration. So that's the enthalpy change of hydration. Now let's look at enthalpy change of sublimation. Are you done writing? Okay. So standard enthalpy change of sublimation. Standard enthalpy change of sublimation. Now we all know what sublimation is. Sublimation. So it is that change of states, obviously, where a substance changes directly from the solid state to the gaseous state without having to pass through the liquid state, or let me say the liquid phase. That is simply what hydration is. And if you are changing a substance from solid to gas, then heat must be absorbed to break the bonds of the solid. And further heat would result in causing the atoms to further move away from one another, thereby getting them to approach the gaseous states and they escape to the surroundings. So we define this as the amount of heat that must be added to a solid. The amount of heat that must be added to a solid at constant pressure to turn it into, we know in sublimation you are turning a thing directly from solid to gas. So to turn it into a gas, without passing through the liquid states under standard conditions. Can you give me an example of substances that sublime? Can you? Are you there? Examples of substances that sublime. What is dry ice? So dry ice is simply solid carbon dioxide. So dry ice is one. Camphor, yes, camphor, iodine crystals, ammonium chloride salts, and all of that. So camphor is same as naphthalene balls. All those are substances that do sublime. Okay, so that we can move on. Then we look at enthalpy change of atomization. Atomization. And this, so standard enthalpy change of atomization. Standard enthalpy change of atomization. Okay, so what is this? Now, this is the enthalpy change where a substance in its standard states is converted into gaseous atoms at standard conditions. So we can say it's the enthalpy change where a substance in its standard states states is converted into gaseous atoms under standard conditions. Under standard conditions. So this I would have to explain small. Under standard conditions. Finish writing so I can explain. Okay. Now, what this means is that, so let's say that you have sodium atom. Please hold on for me. Hold on for me. Hello. Yes, sir. Sit down. Catch up with us. When I don't want the show on Tuesday. They will say I am the show more 10 to 1. I'm more than I am. Sorry, 11 to 1. Yeah. What's the fun class now? For a Tuesdays and the other. Okay. Uh, okay. For mhm, yeah. And it's Wednesday, so the same thing. Me no mushi anopa. Maybe they be a call. Uh, yeah. Mhm. Meaning said the practical will not hold. And Tuesday is naked. Oh, many problem. Yeah, yeah. No problem. Yeah, yeah. Now, a integrated science, no? Would there be an extension of period? Uh, yeah. The no company, yeah, yeah, and it's Wednesday because that's the only day I'm many Johnson alternative.